Did you know that there might be two different kinds of mass? There's the kind that explains why pulling a train is harder than pulling a sled, and then there's the kind that tells you why a train is heavier than the sled. It might sound crazy, but stay with me for a minute. Why should these two ways of thinking about mass be the same thing? As an example, think about a positively charged thing and a negatively charged thing. They attract each other, right? And the force they feel doesn't depend on their masses, just the charges. If you double the charge, the force doubles. The mass only plays a role insofar as that tells the charged thing how fast to move for a given force. If the force is small and the mass is big, it only moves a little bit. But if you increase the charge without changing the mass, then the motion gets faster. And that's something we can do with electric charge. So this notion of mass is called inertial mass, and it's what Bill Nye was talking about.
Inertia is a property of matter.
Now, just like how electric charge is what controls the strength of the electric force, we can describe the strength of the gravitational force between two objects by their gravitational charges, usually called gravitational mass. There's no positive or negative here, just positive, but the idea is still the same. There's a charge that controls the force, and inertial mass translates that force into motion. But the remarkably strange thing about all of this is that, as far as we can tell, there's no way to change the gravitational charge without also changing the inertial mass proportionally. What this means is that the gravitational charge seems to be exactly proportional to inertial mass, regardless of what something is made out of. And this has been tested to extraordinary precision. The proportionality must hold to at least 1 part in 100 trillion. Just think about that for a moment. There's these two seemingly independent properties, but they're always proportional to each other. No other pair of fundamental properties do that. For example, electrons and protons have the same amount of charge, at least their absolute values, but they have different inertial mass. But gravitational mass is somehow inextricably linked to inertial mass, and we have no idea why. This observed property of our universe is called the weak equivalence principle, and it explains why everything falls at the same rate, at least in a vacuum. But what's really remarkable is that a lot of modern theories of quantum gravity and theories of dark energy and more require that the weak equivalence principle only holds as an approximation and should be violated at the roughly 1 in a quadrillion level. So if we don't find any violations, man, gravity just got a lot stranger.